So this board is a very good representation of spermatogenesis, the formation of sperm that occurs in the seminiferous tubules that we were just looking at. So our reference point again is this anaphase and this anaphase. Homologous pairs of chromosomes tells us it's anaphase 1. Dividing sister chromatids again tells us it's anaphase 2. So cells before meiosis 1 over here are primary spermatocytes, and they are formed from the spermatogonia. Once a primary spermatocyte undergoes meiosis 1, we form two secondary spermatocytes. These primary cells would be closer to the surface of the seminiferous tubule. These secondary spermatocytes would be closer to the center of the seminiferous tubule. Each one of these cells undergoes meiosis 2, and then each cell after the division of meiosis 2 produces two cells. So as we see, we start with one cell and we end up with four cells. Now the cells formed by the division of the secondary division of meiosis 2 are called spermatotids to begin with, and then they undergo a differentiation and develop a flagella and a capacity to swim, so then we call them spermatozoa, or what we typically refer to as sperm. So in lab 4 we're going to look at development and the formation of a zygote. So to quickly review some things from lab 3, what's ovulated from a Graafian follicle is a secondary oocyte. And when a secondary oocyte is ovulated, some cells that were part of the follicle are ovulated with the egg. And then the egg is colored by a gelatinous mass that we see as this color right here. And so the cells that are retained on the gelatinous mass of the egg are called the corona radiata, and the gelatinous mass that we see here is called the zona pellucida. And the reason why the polar body that was created by meiosis 1 stays associated with the egg is because the polar body gets trapped under that zona pellucida. So what happens then is a sperm has to wiggle its way through the corona radiata, and then the sperm has enzymes in its head in a structure called an acrosome that digests its way through the gelatinous mass, the zona pellucida, so that the sperm contacts the egg membrane. And the sperm contacting the egg membrane then sets the meiosis 2 in place, so that the egg nucleus quickly undergoes meiosis 2, gives rise to the second polar body, and then the egg nucleus and sperm nucleus can get together to form a zygote. So let's kind of look at that same thing on a little bigger model. So what we have here is we have what we would see is that we have this secondary oocyte. We have a gelatinous mass, the white stuff, surrounding the secondary oocyte, the zona pellucida. Then we have the aggregate of cells that is ovulated with it, called the corona radiata. Okay. So when this is ovulated, then we end up with the secondary oocyte with a single nucleus, with a single polar body. And this represents that gelatinous mass that would surround it, the zona pellucida. And then what happens is a sperm comes in contact with the egg membrane, and that starts meiosis 2 from occurring. So we see this nucleus is in anaphase of meiosis 2, and that creates the formation of the second polar body. So in this model we can see that we have a larger first polar body, a smaller second polar body. And now what we see is the sperm nucleus, which is the blue nucleus, and the egg nucleus, which is the pink nucleus, coming together to form a new individual that is a zygote. We start our lives as a single-celled zygote, and then we go through a process of cleavage that results in cells dividing and doubling in a periodic pattern. So we go from one cell through a process of cleavage to 2 cells, and then quickly to 4 cells. And then during this early development, we're retained as the same size as the original egg, but we're subdividing our cells and making them smaller and smaller and smaller. So as we go through cleavage, we're going to continue to multiply the number of cells and retain the same size. And as we get to a number of small cells, we are a solid ball of cells that we call a morula. And then something mysterious happens in that as we continue to subdivide these cells and make them smaller, all the cells migrate to the surface, and we end up with a hollow ball that we call a blastocyst. And the space inside of that's called a blastocele. So we're going to go from a solid ball of cells, a morula, to a hollow ball of cells that we refer to as a blastocyst. And then a second magical thing happens. A few of the cells migrate inward from our hollow ball of cells, and they form a group of cells that are called the intercell mass. And these cells that form the intercell mass are what the baby's going to develop from. And the cells that now are surrounding it are going to help form the extra embryonic membranes in the placenta that are going to help support you for the next 9 months. So we end up with this inner cell mass forming. So I wanted to review quickly the anatomy of the sperm again. So recall when we were talking about the sperm being able to contact the egg, that it has to digest its way through the Zona Pellucida. So this bag is a bag of enzymes that we call the acrosome. And it's always in the head of the sperm in front of the nucleus. And then the sperm itself, besides the head, which is largely the nucleus and the acrosome, contains this mid-piece here, which would be loaded with mitochondria that give rise to the energy that allows this flagella to swim. And so sperms come in 2 sizes because the X and Y chromosome are different sizes. So larger headed sperms are carrying the X chromosome, which is a very large chromosome, and smaller headed sperm are carrying the Y chromosome, which is a much smaller chromosome. As we look at the developmental periods from conception to when you're born, we can divide those developmental periods into 3 blocks of time. So the first 2 weeks, you were undergoing that process that we were just talking about, where you went from 1 cell to 2 cells to a solid ball of cells, a morula, to eventually a hollow ball of cells, and then forming the inner cell mass from which you're going to form. Then you're going to continue through that process for 2 weeks. So during the first 2 weeks, you are called a zygote. And so this is our zygotic period of development. After that, we have formed our primary tissues that are going to allow us to make organ systems. And from week 3 to week 9, we're going to spend an enormous amount of energy constructing organ systems, such as our central nervous system, our heart, our arms, our legs, our eyes, teeth, palate, external genitalia, and ear. So during the period of time that we are forming our organs, we're in a period called the embryonic period. And then the embryonic period is critical because if women are exposed to agents that can cause birth defects that we call teratogens, then the baby could end up with major morphological abnormalities. Once we go beyond week 8 into week 9 and beyond, we fine-tune the organ systems that we've already been creating. And so we go from our embryonic period to our fetal period. And then we stay in our fetal period until full term. And during this period, exposure to certain compounds don't lead to morphological abnormalities, but can lead to physiological abnormalities or abnormal functioning. of organ systems.